Okay, we're going to take a few minutes to go over homework 1. So question number 1 asked you to find the average rate of change over the given interval, -1 to 3, and to use appropriate units. So just to review what we did the other day, if I'm finding the average rate of change, in this case I'd be finding the change in S over the change in T, S being my Y, T being my X. So if the interval is -1 to 3, I need to figure out what S of 3 is, subtract from that S of -1, and then divide that by the change in X. So I need to evaluate S of 3, and I need to evaluate S of -1. So S of 3 or S of -1, you'd be plugging in 3 for T. If you plug 3 in for T, you should get -2. If I plug -1 in for T, I should get 10. So if I take -2 minus 10 over 3 minus -1, which is really 3 plus 1, I get -12 over 4, which is -3. And then it says to include appropriate units. So just always remind yourself, what does the X and Y, or in this case S and T, represent? So it's meters, because it's always change in Y first, per, or you could do the, also do like the slash, meters per minute. So either format of like how you write your units would be fine. So -3 meters per minute, answer to number 1. Let's move on to number 2. For this one, we're asked to go a little bit farther with the directions, asking us to find the equation of the secant line. So again, the secant line would be the line that goes through these 2 points that are formed from this interval on this given function. So we're going to start out the same, because the slope of the secant line is the average rate of change over the given interval. So I need to find the change in F over the change in X from 0 to 3. So F of 3 minus F of 0 over 3 minus 0. So let's start by just finding F of 3 and F of 0. So 1 over 3 minus 2, that's just going to be 1. And then 1 over 0 minus 2, that's just going to be -1/2. So if I take F of 3, which is 1, and subtract -1/2 in my numerator over 3 minus 0, which is just 3, that's going to give me 1 plus 1/2, which is really 3/2 over 3, which is the same as 3 over 6, which is 1/2. So again, this, just to remind ourselves, this is the slope of the secant line. And now you need to take one of these 2 points, either 3, 1 or 0, -1/2. It does not matter which one. So maybe I'll just do the first one, the 3, 1, all right, and write a point slope line. So again, the format of that is y minus y1 is equal to m times x minus x1. So slope of the secant line, that's our m. And then this would be like my x1, my y1. So y minus 1 equals 1/2 the slope times x minus 3. So that's one way to write the equation of the secant line. If you chose to use the other point, 0, -1/2, then your equation would just look a little different, but it would be the same, idea. Y minus -1/2 would be a double negative. So y plus 1/2 equals 1/2 times x minus 0, or just maybe you would simplify that to just say 1/2 x. So just realizing that like these are both equal, they're both correct, like final answers. It wouldn't matter which point you chose to use when writing the equation of your secant line. And then for number 3, I know it looks more complicated, and I saw a lot of homework submissions already that kind of just feel like people were not sure what to do. It's the same exact direction as above, right? We're writing the equation of the secant line, so we have to start by finding the slope. So change in H over change in T, which means I'm looking to do from the interval pi over 10 to pi over 5. So maybe H of pi over 5 minus H of pi over 10 over pi over 5 minus pi over 10. So that's the goal. right? First, we have to figure out what these two actual outputs are from h of pi over 5 and h of pi over 10. And I am plugging into a trig function. So this first one would be the cosine of 5 times pi over 5. So the 5's would cancel. I get the cosine of pi. Just to remind ourselves, pi is a quadrantal angle. It's 180 degrees. It's over here. It would be at the point -1, 0. Cosine is the x, so we get -1. So the cosine of pi over 5 times pi over 5 would be -1. And then let's look at the other one, cosine of 5 times pi over 10. Now this doesn't cancel, but 5 pi over 10 would be pi over 2, which is also quadrantal. It's up here. Pi over 2 is 90, and that's at the point 0, 1. So for this one, the cosine is 0. So the 2 points that we just got, pi over 5, comma, -1, pi over 10, comma, 0. These are the points we just used. Now we're going to find our slope between them, or these are the points, excuse me, we just found. Maybe I'll move this so I have a little room. Okay, so pi over 5, that was our -1, minus pi over, h of pi over 10 was 0, over pi over 5 minus pi over 10. If I wanted to just quickly come up with like a common denominator to do that, multiply by 2 over 2, right? That would be now 2 pi over 10. So 2 pi over 10 minus 1 pi over 10 is just 1 pi over 10. So we get -1 over pi over 10, which is a complex fraction. I'm going to multiply by the reciprocal. And if I multiply -1 by 10 over pi, I get -10 over pi. So again, this is the m. This is the slope of the secant line. So now I'm going to take that with one of my points. So let's maybe take this point, and this is my slope. Let's write our equation. So y minus -1, so y plus 1 equals the slope, -10 over pi, times x minus, and then the x value in the point is pi over 5. So that's one option. And they also did write this as h of t, so maybe I'd change the y to be h of t. But you don't have to, you could leave it as y. And then the other one, if I use the second point, let's say, just to show you that they would both be acceptable answers, this would be y minus 0 equals -10 over pi times x minus pi over 10. So these two equations, whether you leave them as y's or, let's bring that back, fix it as h of t, these would both be acceptable final answers in your work. Okay, I hope this was helpful going over the homework. The next video will go over lesson 2.